Hello, everyone. So this lesson is going to shift from, the previous lesson talked about interior angles, and now we're going to talk about exterior angles. And when we talk and discuss about exterior angles, one thing you need to know is what is an exterior angle? Well, if I go ahead and I take, right, a polygon, and I extend each side like such, what happens is we get these angles outside, okay? Now, what we know about each of these angles is they're an extension, they're adjacent to the interior, so they're adjacent, meaning neighboring and share the same vertex, to the interior angle, and it's actually outside the angle. Now, looking at this polygon has one exterior angle, two exterior angles, 3, 4, and 5 exterior angles. If you look, the number of exterior angles is always equal to the number of interior angles, which is always equivalent to the number of sides a polygon has. Okay. The other thing I want you guys to notice is when you look at the exterior and interior angle, the exterior angle plus the interior angle add up to 180 degrees because they form a linear pair. This can be very important to understand. So an exterior angle is basically an angle outside the polygon formed by one of its sides and the extension of an adjacent side. Okay, so let's take a look at this. Find the exterior angle sum of a polygon. Here you're given a regular pentagon, right? So find the measure of each interior angle of this regular pentagon. Now remember, in a regular pentagon, all sides and all of these angles are congruent. So if I look for the interior angle sum, that would be the number of sides minus 2 times 180. Which gives us 3 times 180, which is 540. Now, to find the measure of each interior angle, I'm going to take the sum divided by the number of sides, n. So in this case, 540 divided by 5, right, would give me 108 degrees. So each of these interior angles is 108 degrees. Now, how can I find the measure of each exterior angle? Well, I know the interior plus the exterior are supplementary or add up to 180. So the interior is 108 plus I don't know the exterior. Right? When I solve for the exterior by subtracting 108, I would get 180 minus 108. So each exterior angle is going to be 72 degrees. Now, once I find the measure of each exterior, if they're all the same and I have 5 of them, the exterior angle sum would be 5 angles, each having a measure of 72 degrees. 5 times 72 would be 360 degrees. So in this pentagon, if I were to take each of these exterior angles and add them all up, they would have a sum of 360 degrees. Now, let's go and look at an octagon. If I look at an octagon, it has 8 exterior angles. 1, 2, 3, 4, 5, 6, 7, 6, 7, and 8. So it has 8 exterior angles. So if I find the interior angle sum, that would be 8 sides minus 2 times 180, as from yesterday's lesson. 6 times 180 would give you 1080. So all 8 of these interior angles will add up to 1080. So each interior would equal the sum divided by the number of sides. So 1080 divided by 8 would give you 135. So each of these interior angles would be 135 degrees. Now, the exterior angle then would be 180 minus the interior angle. So that's going to be 180 minus 135, which would give you 45 degrees. So now, each of these exterior angles is 45 degrees. So the sum of the measures of the exterior would be 45 times 8, which is 360 degrees. So what you'll notice or can conclude here is that the sum of the measures of the exterior angles of a polygon will always be 360 degrees. No matter how many sides it has, it will always be or always have a sum of 360 degrees. Okay? So the exterior angle sum of a polygon is always 360 degrees. No matter how many sides it has, it will always be 360 degrees. First example here, find the sum of the measures of the exterior angles of a decagon. Well, sum of the measures of the exterior decagon is number of sides, but no matter what, as soon as we see sum of the measures of the exterior, we know our answer will always be 360 degrees. Now, example 2, find the measure of each exterior angle of a regular dodecagon. Dodecagon means 12 sides. So each exterior, if you think about it, each exterior angle will equal the exterior angle sum divided by the number of sides. So in this case, it would always be 360 divided by n. So when I do 360 divided by 12, that would give me each exterior angle would have a measure of 30 degrees. Example 3. If I look at each of these angles, they represent one exterior angle at each vertex. And what do all 4 of those angles add up to? Well, if I take 3x plus 4x plus 2x plus x, add them all up, since they're exterior angles, they should all add up to 360. So 7, 9, 10x equals 360. Divide by 10, x is equal to 36. And we are done. Now here's where it gets a little tricky, right? And this is where we got to really think about what we have and know how to use it. Here it says, name the polygon if the sum of the measures of its interior angles is 3600. Well, what I like to do is what they give me, I like to write that formula out. Sum of the measures of the interior angles. I know interior angle sum is the number of sides n minus 2 times 180. So I'm going to take this and I'm going to say, okay, number of sides minus 2 times 180 equals, what was the interior angle sum? 3,600. Now, here's what I'm going to do next. Solve for n. I'm going to divide by 180, and that leaves me with n minus 2 equals 3,600 divided by 180 gives me 20. So, n minus 2 equals 20. But now, I have to add 2 to both sides. And n would equal 22. So this would be a 22 gon. All right. Now, next, they basically they say name the regular polygon if each exterior angle is 15 degrees. So remember, each exterior angle equals 360 divided by the number of sides. Well, think about this, right? If I had to solve this equation for n, I would basically flip-flop n in each exterior angle. So n multiplied by n, these cancel out, multiply by n, I get n times the exterior angle measure equals 360. And if I solve for n, I would divide both sides by the exterior angle. So the number of sides is equal to 360 divided by the exterior angle measure. So in this case, n equals 360 divided by 15. Here you do not have to add 2, but 360 divided by 15 gives you 24. So this would be a 24 gon. And last, name the regular polygon if each interior angle is 170 degrees. Well, here's the thing. There's not enough information to use just the interior angle. But if I draw any polygon, when I look at it, if I extend the side of any polygon, I know the interior angle plus the exterior angle will always add up to 180 degrees. So if my interior angle is 170, I know my exterior angle is going to be 180 minus 170, which is 10 degrees. Now, if I look at example 2 here, I'm going to say the number of sides n is equal to 360 divided by the measure of each exterior, which is 10. So this would be 36. So this would be a 36 gon. So guys, remember, if you're given each interior angle, you are going to use that to find the measure of each exterior, and then you're going to use the formula, number of sides equals 360 divided by the measure of the exterior angle. Go ahead, attempt the homework, and let me know if you have any questions.